Hello and welcome back to Brainwave. Today we're going to be learning about molecular forces, the forces between atoms, ions and molecules. To learn about how atoms, ions and molecules interact, we need to know about the forces that hold them together. We can break molecular forces into two broad categories, intramolecular and intermolecular. We can remember this by looking at the Latin roots. The Latin root of intra means inside, and the Latin root of inter means between. So we can deduce that intramolecular forces are the forces between atoms, and the intermolecular forces are the forces between molecules. Let's start with intramolecular forces, what you might know as chemical bonds. Chemical bonds are known as intramolecular forces, the forces that bind together the atoms which make up a molecule, of which the classical model identifies three main types: Ionic bonding, covalent bonding, and metallic bonding. These bonds describe how atoms, ions and molecules are attracted to each other to form compounds. For example, a common example would be table salt, which is sodium chloride, formed from sodium and chlorine ions, which join together via ionic bonding. Intermolecular forces are the forces between the molecules themselves. The three examples would be hydrogen bonding, van der Waals forces of attraction, and dipole dipole interactions. A common example of an intermolecular force would be the forces that hold water molecules together. For example, there is a bond known as a hydrogen bond, which occurs between the hydrogen atom on one water molecule and the oxygen atom on another water molecule, which we can go over in another video. So why do atoms, ions and molecules want to form these bonds? Well, we have something called the Octet Rule, which is an observation that main group elements tend to bond in such a way that each atom has 8 electrons in their outer shell, the valence shell, which gives it the same electronic configuration as a noble gas. This is known as a stable configuration. We can show this with the example of carbon dioxide. Carbon has got 4 electrons in its valence shell, seen by here, 1, 2, 3, 4. Oxygen has got 6 electrons in its valence shell, 1, 2, 3, 4, 5, 6. In order to become stable via the Octet Rule, carbon would need to gain or lose 4 electrons in the valence shell, and oxygen would need to gain 2 electrons in its valence shell in order to become stable. One way it can do this is via something called a covalent bond. If we draw carbon again, with its 2 outer electrons, and we draw 2 oxygen molecules next to it, if these molecules share electrons, they can become stable. So now if we count again, this oxygen molecule has got 8 electrons. 1, 2, 3, 4, and 4 that it's sharing here. This oxygen molecule here has got 1, 2, 3, 4, and 4 it's sharing. So they both have 8 electrons in their valence shell. And the carbon molecule in the middle has also got 8 electrons in its valence shell. This means that this molecule is now stable. This sharing of electrons is called a covalent bond. Let's review. So we've covered the difference between intra and intermolecular bonding. We've identified the main types of intramolecular bonding, which is ionic, covalent, and metallic. And we've identified the main types of intermolecular bonding, which are hydrogen bonding dipole-dipole interactions, and van der Waals forces of attraction. Thank you very much for watching. I'll be doing some more videos on the different types of inter- and intramolecular forces of attraction. If you like the video, please don't forget to like, comment and subscribe, and I'll see you for the next video. Thanks again. Bye-bye.